Welcome back, students. We are going to discuss same chapter number 3. But from this chapter, one of the most important topic is Kirchhoff's laws. Kirchhoff having two laws. First is also known as KCL. What is KCL? It is Kirchhoff's current law. And Kirchhoff's current law is applicable for a junction only. What do you mean by junction? So, in any network where electric current is divided or it combined, right? That point is known as junction point. Okay, what is this? What is the first rule? And for that, we have used few reference books. For an example, Darpan as well as modern, right? To make this topic simple, what is KCL? Let us say, consider a small part of network where 5 wires met like this. Say wire number 1, 2, 3, 4 and 5. So here at this point all the wires meet. This is known as junction. Okay, consider electric current is entering or coming out from the junction or in the junction. Means in few of the wire electric currents are entering, but from few of the wires electric current is coming out. Give it name: I1, I2, I3, I4 and I5. So from the figure it is clear that I1, I2 and I4, they are entering inside the point on a junction, but I3 and I5, these two electric currents are coming out of the junction. Got it? So there is a sign convection. The electric current which are entering, you have to take it positive, and the electric current which are coming out, you have to take it negative. But after all, at the junction electric current will remains 0. So what does it mean? How? Let us say. So from figure electric currents are entering, that is I1 plus I2 plus I4. They are entering in a junction, but I3 and I5, they are coming out from the junction. Take these two on this side, so it will become minus. So you will have I1 plus I2 plus minus I3 plus I4 plus minus I5 is equal to 0. Means here you can say that algebraic sum of electric current, all the electric currents at the junction is 0. So this thing you can write in a symbolic form is algebraic sum of electric current is 0. Where it is 0? It is at the junction, right? So this is the mathematical expression of Kirchhoff's first law, which is known as current law also. Okay, and from this equation we can write the statement of Kirchhoff's first law. What will be its statement? So its statement is like this: at the junction algebraic sum of I means algebraic sum of I means electric current becomes 0. What becomes 0? Algebraic sum of electric current. So this is its statement. Again, algebraic sum of electric current at the junction becomes 0, or you can say that instead of becomes, remains 0. Okay, so this is first law of Kirchhoff. Now let us see second law. Second law is also known as KVL, means Kirchhoff's voltage law, and Kirchhoff voltage law is applicable for a loop only. What do you mean by loop? From the starting point, electric current go anywhere, but when it come back to the same point, so you can say that electric current has covered entire loop. Means the starting point as well as the ending point of electric current must be same in a network that is known as loop. Okay, so for this you have to refer one figure which we have taken from GSEB textbook as well as from the reference book. What is there? Let us see. You have to prepare a loop. In the shape of pentagon. Got it? So this is the starting point, that is A. Right? Here there are resistors, okay? You have to put two batteries, two cells. First battery having EMF E1 and second battery having EMF E2. Give the name of resistors, that is R1, R2, okay? Now, for our conveniency, think of this only. Electric current passing through R1 is I1. Electric current passing through R5 is I5. Same direction. It is for our understanding only. So don't think about positive terminal and negative terminal of a battery. Okay? Electric current passing through R2, I2. Passing through R3 is I3, and passing through R4 is I4. Okay? Give the names. So starting from A, B, C, D, E and EA. So here one loop completed. Okay, to solve this loop there are few rules which is known as sign convention, right? So we also have to understand the sign convention, how it works and how we have to use for this. Ready? So first sign convention is you have to go in a loop is clockwise. Means from the A, you have to move like this, clockwise. Okay? So this is the first rule, clockwise. What is the second rule? If we are moving clockwise and if electric current is in direction, means second sign convection depends upon direction of electric current. So if electric current is in direction, then at a resistor electric potential drops, means down arrow. And because of this reason, V is equal to IR. This value you have to take negative. Okay? Then similarly, if electric current is in which direction? Opposite direction, then at resistor electric potential gains, and because of that V is equal to IR, you have to take positive. Okay? Then third sign convection is here. Which is it? If in the direction, if you will have positive terminal of a battery, then its EMF is taken as negative. Means if there is a positive terminal of a battery, its EMF is taken as negative. And if there is a negative terminal of a battery, its EMF is taken as positive. So these are the rules for sign convection. While you are using Kirchhoff's second law, you must have to follow these rules. First rule is clockwise, means in a loop you have to go clockwise. If electric current is in the same direction of our path, so at that time V is equal to IR, you have to take negative. Why? Because at that resistor electric potential drops and vice versa. While moving clockwise, if you will have positive terminal of a battery, then its EMF you have to take negative. And if there is a negative terminal of a battery, its EMF you must have to take positive. Okay? Then how to apply these rules? How this rule works? Right? Apply all these rules for this loop. Ready? Let us see. Starting from A. I1 R1. But see, I1 is in the direction of clockwise. So I1 R1 IR you have to take negative. So it will be minus I1 R1. Oh, there is positive terminal of a battery. Its EMF you have to take negative. So minus E1. Got the idea? No problem. Let us see. There is BC in between R2, I2. We will put the sign afterwards. Then EMF E2, I3 R3, I4 R4, I5 R5. Again point A means 0. Electric potential is same. Got it? Here in first side only we took the sign. Now let us understand. Come to this point BC. Between B and C there is IR means I2 R2. But while we are moving clockwise, electric current is in opposite direction like this. So if it is in opposite direction, you have to take IR value plus. So it is plus CD, negative terminal of a battery. So its EMF E2, you have to take plus I3 R3. I3 is in direction, so you have to take it minus. What about I4 R4? We are going like this. So this is our direction, but I4 is in opposite direction. So which cell will be there? Very good. It is plus. Again I5 is in opposite direction. Again it is plus. Good. Got it? Then what to do? Take E1 and E2 on this side. So it will becomes negative. E1 negative on that side positive. E2 plus on that side it will be minus. So what will remain? Same. Minus I1 R1 plus I2 R2 plus minus I3 R3 plus I4 R4 plus I5 R5 is equal to what? E1 on that side it is minus. Now it is plus E2. It is positive but on that side negative. So minus E2. Now what is this? Sum. It is the thing but algebraic sum of IR. So you can say that a product of electric current passing through its resistor and its algebraic sum is equal to sum means again algebraic sum of whose algebraic sum, that is EMF E. Okay, so this is the mathematical expression of Kirchhoff's second law, and this is for a loop only. As first law was for a junction, same way second law is for a loop. See, this is the very important topic. So have a look. These are about sign convection. It is easy, and we have to use this sign convection for this loop. Okay, just you have to remember, you have to go clockwise, and if you want to go anti-clockwise, then all the conditions must be reversed. Okay? To understand this, let us take one numerical. It is from the textbook, and let us take for our convenience, it is illustration only. Okay? See, in this illustration number 3.6, there is a battery of 10 volt. Check from the textbook only. It is the figure C. Okay? It is illustration number 3.6. From the questions, there is a cube which is made up of 12 wires. So, first of all, let us take a cube which is made up of 12 wires. So, 1, 2, 3, 4 wires, 4, 5, 6, 7th wire, 8, 9, 10, 11 and 12th wire. Right? So, there is a cube which is made up of 12 wire, and each wire having resistance, as it is given in our textbook, each wire having resistance 1 ohm, and it is connected with a battery having electric potential. How much? 10 volt. Why we have taken this illustration? This is illustration number 3.6. It is one of the most important illustration, and which was asked so many times in board exam. We know that from the positive terminal electric current flows, that is I, but here electric current is divided into 3. So let us take it is 3I electric current. I. It is 3I. Got it? The same electric current will go here. It is divided into further 2. So it is I by 2. It is I by 2. Same way, electric current of this branch is again, it is divided into 2. For this, electric current is divided into again 2. That is here I by 2, I by 2. So it is 2 currents meet here, I by 2 and I by 2. So it will become I. Similarly, I by 2, I by 2. From here, I. Same way, I by 2, I by 2. All these 3 current, 1, 2 and 3, they meet here. So, according to Kirchhoff's first law, I. So, it is 3I. Again, to the negative terminal of a battery. Okay? So, by this way, you can distribute electric current with the help of Kirchhoff's first law. how to solve it. Okay, what is asked in our question? So it is there, what is the equivalent resistance of a network? Means each wire having 1 ohm resistance. So you have to move in a loop, and for that we have to find equivalent resistance. For that you have to follow any one loop. Any one loop means any one. Starting from here, A, B, C, D, and then battery having electric potential. How much? 10 volt. Forget about anything, everything. You have to go for A, B, C, D, and then battery having EMF 10 volt. Okay, let us see. You have to apply Kirchhoff's second law. Think of that. Think of the loop. Let us see AB. So we are going to apply Kirchhoff's second law for a loop A, B, BC, CD, D, and battery, and again A. So this is a complete loop, and you have to apply Kirchhoff's second law. Okay, forget about all this. Start from here. AB. See, electric current is in our direction, so it is I. Here resistance of a wire is 1 ohm. Okay, so this resistance is 1 ohm, so I multiply by 1. Electric current in this direction, in our direction, so let us take minus. Okay, here BC, again electric current in same direction, so that term will also be minus. I by 2. This is the wire having resistance 1 ohm. CD, electric current is I, that is I, but it is in our direction, that is clockwise direction, so it is also minus. Again there is a wire having resistance 1 ohm. Now a battery positive terminal, negative terminal, its EMF you have to take positive, that is 10 is equal to 0. Okay, so what will remain? That is minus. So this is the idea for how to use that Kirchhoff's second law. Okay, if you will refer the textbook, page number 116, illustration number 3.6, then you will get the idea. Okay, and if there is any doubt, in our school we will solve it. So this is just an idea for what? How to use Kirchhoff's second law and how to put the sign. Okay, for our conveniency, let us see once again for Kirchhoff's second law which things you have to remember. First thing is about clockwise, about the direction, clockwise. In short, second, if electric current is in same direction, then V is equal to IR. This value you have to take negative, If electric current is in opposite direction, then V is equal to IR. This value you have to take positive. Third, while moving clockwise, if in our path we will get a battery, and in a battery, if there is a positive terminal, then its EMF means battery's EMF you have to take negative, and if there is a negative terminal of a battery, then that EMF you have to take positive. Okay, so these are the short form of Kirchhoff's second law. While we are using Kirchhoff's second law, you have to remember this sign convention. Thank you.